Hello, in this video I will perform a z-test for a proportion. This example states the following. Assume that a fisherman wishes to test a hypothesis regarding the proportion of yellowtail tuna he captures during the summertime. He claims that this proportion is greater than 20%. So for this type of test, let me correct that there. The fisherman wishes to test a population proportion which is labeled as P. In order to conduct the test, he collects a random sample of 100 fish during the summer and finds that 32 of them are yellowtail tuna. And so we will perform the test. We've already verified the inequalities that allow us to use the z-test. Our next step is to select the confidence level, actually the level of significance, which is alpha equal to 0.05. So now we have to state the claim. The claim is that the proportion of yellowtail in the summertime is greater than 20%. That's the claim. That's H sub 1. H naught would be P is equal to 20%. So we draw the normal distribution. Since we have a greater than amount, that's a right tail test. And we look up the critical value in table F. So one tail, 0.05, we go all the way down to the z value, and that's 1.65. So that's the critical value. It's the value that separates the critical region from the non-critical region. Next, we have to calculate our sample proportion p hat. That's x over n. So x is the number of yellowtail. That's 32. N is the sample size, 100. So 32 divided by 100 is 0.32. That's our sample proportion, which is said as p hat. P is our population proportion, which is 0.2. Q is the proportion of fish that are not yellowtail. That's 1 minus 0.2, which is 0.8. Our next step is to compute the test point. So the test point formula is z equal to p hat minus p divided by radical p times q over n. So p hat is 0.32. P is 0.2 divided by the square root of 0.2 times 0.8 over 100. Let's calculate this using a standard scientific calculator. I like to use the parentheses, so we have 0.32 minus 0.2, and I like to type it all in one shot. I don't like to work it out in parts. We divide this by the square root, and we keep everything inside. 0.2 times 0.8 divided by 100. And we can see we get 3. So 3 is the test point value. Now we make the decision. We compare 3 to the critical value. It will be to the right, thus the test point falls in the critical region. That means we reject H naught. Remember, the test is always to reject or not reject H naught. We finally summarize. We can use this little table to help guide us. The claim is H1. We rejected H naught, so we say there is enough evidence to support the fisherman's claim. Thanks for watching the video.